Okay, so probability, what is it? It's the, and we're going to talk about different things: theoretical probability, relative frequency, and how to construct a probability distribution. We've done all these things before, so don't today just give them new names. All right, don't freak out. So they're going to talk about probability, easiest thing they ever done. We all do it. Flip a coin. You have a 50-50 chance of each thing happening. Well, if you flip it twice, well, now we have different things that occur. We can have no heads. We can have one head with a tail and a head. We can have a head and a tail. Or we can have two heads. So these are the outcomes that are possible when we flip a coin twice. And here they're looking at, okay, well, what happens, if we're only looking at heads, notice that the two middle ones here have the same outcome. They both have one head that occurs. All right. So these are the same event. And this is another important word that you're going to hear: event and outcome. All right. We're talking about probabilities. So while there are four possible outcomes, there are three events, because we can have tail tail, tail head, head tail, and head head. Those are the different outcomes, but the events are having no heads, one head, or two heads. Okay, so that's the big difference between the two, is that outcomes are the basic things. The order is important. Whatever can occur, occurs. Whatever you see has occurred. Whereas the events are the collection, and some outcomes may share the same, may become the same event. Okay, they say the same property, because in this case the order isn't important. So if you have three kids in your family, you can have no boys, you can have one boy, you can have two boys, or you can have three boys. Those are the events, but the outcomes could be girl, 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 boy, girl, 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 boy, girl, 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 boy. So there's three different ways to make one boy in a family of three children. So that's the big difference between those, between outcomes and events. So probability has to be between 0 and 1 inclusive. So we can have 0 probability, means it's not going to happen. Christmas never, ever, ever occurs in August. Okay, and a probability of 1 means that it will always happen. So Easter is always on a Sunday. Those are things that have a 0 occurrence, a 0 probability on 1. Though they don't happen that often. Most things happen in between. And now you can see why a normal curve, the area under the normal curve, can kind of be considered probability, because we have the whole area adds up to 1. Okay, so we can have nothing, we can have everything, and we can have all the spaces in between. So therefore, those percentages can be looked at as probabilities. All right, and that's where the statistical significance comes into play from the last section that we were talking about. That's why it's probability. And here they show you a nice little graph. We have nothing can occur. It's always going to occur. And then a 0.5 probability, well, 50-50 chance. Everything is even. If it's less than 0.5, it's unlikely to occur. And if it's more than 0.5, it's likely to occur. So that scale just kind of gives you a view of where the numbers can go. Remember, if you write down that you have a probability greater than 1, you made a mistake. Go back and fix it. It's important. You can't have more. You can't have something more than 100% likely to occur. So a theoretical probability, what we do is we count the number of possible outcomes. And then we look to see in the ways of the event of interest. Notice the event of interest is the one that we're looking for. So in the flipping coin, we talked about heads. In kids, three children families, we're interested in the number of boys. Okay, we look to see how many times can that occur. And then we figure out the probability by dividing A, which they say is the number of ways the event can occur, divided by the total number of outcomes. And we can just leave it as a fraction. In most cases, we do leave it as a fraction, or we turn it into a percent or a decimal, just depending on what they're asking for. But a fraction is a perfectly um, fine way to leave a uh, probability, but make sure you reduce it. So if I have outcomes, all right, and here they're talking about 2 coins, we can make a diagram here, a tree diagram. This all they're doing is they're just showing how it splits up. So coin 1 was either a head or a tail, and then we flipped the coin 2, we got either a head or a tail. And the same thing. So notice our outcomes were head head, head tail, tail head, tail tail. So that's what we do. We count up when we just make a list, and we make sure that everything gets included, and that's why they're using the trees, so that they make sure that they get to all the possible choices. Because not always are the same things going to occur the same amount of times. You may have one thing and have 2 choices, and one thing and have 5 choices, and so you have to make sure that they all line up and they're all taken into account, so you can get your right outcomes. So the total number of outcomes is 4 because, well, we have 2 things that could occur for the first one and 2 things that occur for the second one. So 2 times 2. We just multiply the number of things that occurred to find our value. If we had 3 coin tosses, we would have 2 times 2 times 2, or 8 possible outcomes. Right, so to find out how many outcomes you have, you just multiply the number of choices you have for each thing that you're doing. And see here, I get ahead of myself as always. If we have 3 flips, we have 8 because we have 2 times 2 times 2. So here's coin toss 1, coin toss 2, where we took our tree, and then coin toss 3, where we have each thing going to a head or a tail on the next flip. So we can have head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. So I still don't have a lot, even though I have 8 different outcomes, I have overlapping events. I have 3 heads. I have 2 heads. I have 1 head, and I have no heads. So even though the amount of outcomes is 8, the amount of events is only 4. So here they're saying counting outcomes. You'll find out how many ever things A has, possible outcomes, times the number of things B has, and if we have 3 of them, times the number of things C has, and times the number of things D has outcomes, and times the number of E outcomes. You just multiply them all together. Okay, that will tell you how many possible outcomes there are going to be. Very easy. Relative frequency. So the first one was theoretical, where we look up into the sky and say this is what can occur, theoretically. So relative is approximate. We actually observe things going on. So theoretically, there is a 1 in 4 chance of getting 2 heads when you flip coins. Now, if I flip 2 coins, 100 times, I'm not necessarily going to get 25 of those to be 2 heads. I might get 30 of them at one time, and then 20 of them the next, and 6 the next, and 50. So because relative frequency looks at what actually happened. So these are samples. So we're looking at frequencies of probability frequencies of samples. And so they call it the empirical method because that's actually studying something, or a relative frequency method. So you do the process over and over again. You find out how many times A occurred, and then you divide it by the number of things you actually did. So you're still dividing to get the probability, but in this case you're not taking theoretical numbers, you're taking actual observed occurrences. Okay? That's the big difference between the two. Subjective probability is one of those things, there's no number, it's just kind of a thing you feel, and it's by experience. And here they're showing you We're going to see an example of it in a second. It's kind of a weird one to talk about, but it's usually, you're basing your knowledge of a person on what you think they're going to do. There's a 20% chance that you're going to get married, type of thing. That's the actual example that they come across. So that's what a subjective probability is. They're, not as useful. So theoretical is based on assumptions and what should occur in a I can't think of the word I'm trying. Overall. So if you did this a million times, if you did this an infinite number of times, this is what should occur. Now, relative frequency is what you actually notice occur. So because we're always doing short amount of samples of things, so those are the things that we observe occurring. And subjective is an estimate based on experience. So, and here they give you one. The chance that you'll get be married by next year is 0. That is subjective. That's what you're basing it on. Okay, there's no numbers that I can say, there's no formula that comes up and says, you should be married, if you're 26, you're married, 38% of the time. It doesn't work. It's just, you're basing it on the person that you're talking to. Whereas B and C talk about actual things. So here A, they say is subjective. B is relative because it's based on observations. So based on government data, the chance of dying in an automobile accident is 1 in 7,000. They look at all the data, all car crashes and deaths resulting from that, and they say, these are the number of things that occur. Whereas the third one is, statistical. Rolling a 7 with a 12-sided dice is 1 in 12 because, there's 12 sides and there's only one 7 on the 12-sided dice. So that's why this one is a theoretical probability. Okay, it's assuming that things are fair, that you have a 12-sided dice, everything is equally likely to occur.